तर मी स्टार्ट करतो. Good morning to all. Am I audible?
Yes, sir.
Great.
Yes, sir. Good
So,
morning.
good morning. Good morning. So, very thank you that on this Sunday morning we have all joined and we are taking our exciting journey into IoT and sensors. And now, today, we will be talking about 5G network, how the 5G network is going to interconnect with the IoT. So, thank you for joining us on this Sunday. So, let's start with our today's session. Today, what we will be doing is we will be going to understand what exactly a 5G network is. So, we are not going to understand a 5G network in a that technical aspect of a telecom, but we are going to understand it in aspects of Internet of Things. So, how exactly these smart devices, which can be connected on the 5G network, and 5G can leverage some kind of advantage over it, or what kind of exciting things 5G is offering to us in order to have the smart automation or kind of applications develop, or we can have a hardware implementation on that. But unfortunately, it is in a view that in India still there is no the 5G implementation yet, but very soon we will be having a 5G implementation. But still that time we can have some kind of advantage over a 4G network. Give me a minute only. Yes, very sorry. So, big credit to Qualcomm Industries that I have borrowed their presentation only. So I have not made any presentation by my sources. So I have taken a source from a Qualcomm because I found this presentation is very what we can say attached to our technology, and it is specifically designed for IoT innovation. So how exactly IoT can be implemented over the 5G network, as Qualcomm is a biggest company or the manufacturer of wireless sensing networks or the devices, what we can see. Even some of us are having Qualcomm WLAN NIC on our laptop. So that is what wireless network interface. So this is a very old company, and having a specific area or focused area of a business, that is what the wireless device is. So they are not only producing NICs, that network interface cards, but they are producing some nodes, WSN nodes, WSN sensors. Even in telecom, they are creating telecom bus, then SMB devices, routers, then antennas. So lot of thing Qualcomm is contributing. But Qualcomm is what? Qualcomm is not a front end player; it is a back end player. So definitely some players like Huawei and all taking Qualcomm's devices, rebranding them, and they are selling it. But Qualcomm is having a specific R&D department where they are researching on 5G technology. So they have made a very beautiful presentation with the all the aspects of IoT and 5G, how the IoT is interconnecting with the 5G, and 5G network enabling all the facilities what we can use. So if we can see over here, so 5G network is a intelligent wireless edge computing network. So it can provide you a privacy, then it can provide you immediate delivery, efficiency in communication. It is a reliable and it is personalized service. So if you can see all these kind of services, so you might think about, okay, this can be a very costly or a high cost devices or a high energy consumption devices, because we are getting privacy, we are getting immediacy. Means what? We can get an immediate response over the query. So the connectivity connectivity is very fast. In our last session we saw we need to have interpretability, and on the consultation we need to have a immediate boot ability. So your devices needs to be ready on the network to produce tasks as soon as it got power. So that is what the immediacy is. Then efficiency, it is having a very minimum latency. I think someone's mic is on. Okay. Yeah. So efficiency in other manner, it is very important once we are having our node deployed, or when we are having our devices deployed, the how that device is behaving, what kind of efficiency that device is producing in terms of recording a data, collecting a data, sending a data, or whatever the instructions are passed to that node or that sensor node that needs to obey that instruction and perform their task. So that is what the efficiency is all about. Means we can consider efficiency is equal to throughput, and better throughput, better the efficiency we get. Then we will be having a reliability. Means what? If we are having a particular sensor which is connecting on the network, now the reliability of that sensor is much higher in the 5G network, because that 5G network is super, or we can say ultra fast in communication. That's why a slightest delay is not possible in that case. So there is a low delay or the low latency, and that's why we can have a better performance over the channel. So we can rely on that particular device to carry out our transaction. Even that devices are having efficient work, or the what we can say efficiency of producing a meaning, or the producing a proper work throughput. So that is the reliability. And of course, whenever we want, whatever we want, we can customize, and according to the customizations, that device can be fitted in our application. Maybe in different application areas, I'll be taking up some use cases, and the beautiful use cases what Qualcomm have defined. So those are a very real time use cases. So in that case, so particular thing, if we wanted to have like a personalized way, like for example, if we are taking our use case, then I'm having a rover with me. So if I wanted to customize my quadcopter or a drone or the rover, I wanted to have profiles in it, then I need to enable uh, what we can say collision detection and avoidance system. Then I need to detect the obstacle. I wanted to find out which objects are there. I want that my quadcopter is, when it is reaching to a target waypoint, it needs to identify that person and perform the various tasks. If I'm using that drone for a delivery, or delivery drones, if I'm making it. So on top of that, whatever the sensing bed I'll be having on that drone, that needs to be customized in a manner where I can have my customization fitted, and I can navigate my drone as no one is navigating, or I can make that drone better in performance. So that is what the personalization is. Even I can control my drone with the various profiles, and the personal profiles I can give to that drone. So that's why it is a personalized one. So looking at all these feature, we might think about like this network or the network device what we are going to connect, it is having a very high power consumption, or which will be maybe having a latency enough in that. But 5G is not only a low latency network, it is a very very low power consumption network as well, resulting whatever the device you are creating using 5G nodes or the 5G connectors, they will be a very they will operate on a very minimum voltage, though it is saving your battery backup, or it is saving your energy. And once you wanted to fit it onto a battery operated environment, then that battery will give you a proper usage, and your battery life can be increased, and your payload life can be increased. Now when I say payload life means what? If I'm using a drone right now, I'm using a lipo battery in my drone. Then it is a 3 cells 11-volt battery, and the flight time what I can get on the full charge. So there are 3 cells in that lipo battery. So if I charge all the 3 cells properly 100%, so I'll be getting only a 15 minutes of a flight time. But if I'm increasing my capabilities of a communication, because a lot of energy is consumed by my flight controller, then onboard GPS, elementary device what I have connected. So these three devices, which are a very crucial devices in terms of a navigation. And definitely each motor, each BLDC motor, that is a brushless DC motors we are having. So on that each BCDLC motor, it is requiring 5 to 9 volt depending upon the pressure of the wind. So if this rover is taking off, then uh, my motors will drain at least a 9 volt each. So I'm having four drones, four BLDCs with me. So each BLDC, each motor will draw a 9 volt battery. And after that, when it is reaches to a certain altitude on the hover position, with the help of friction in the air and the air gap, then what we can say, atmospheric pressure, using a barometer on my flight controller, it is controlling its height, and it is holding that height. And then automatically my energy consumption is getting tuned to a 5 volt. But this can I can control mechanically. But when I wanted to navigate my drone on a certain position, then I'll be using a GPS. I wanted to make that drone do some tricks, like it needs to fly around, it needs to turn, it needs to flip. So all these kind of a maneuver what my drone needs to perform, and I'm giving the instructions through my remote control or through my mobile app. So there is a telemetry or remote control sensing module is attached to my drone. So that is also taking a power from my battery. Even the network connection what I'm using. So instead of this, if I'm using a cellularly connected drones, or the devices which can be connected to a cellular network, and then I can use my controller application installed on my phone or on my laptop, I can control my drone. Yes, it is possible, and we can do it with the existing 4G LTE network. It is not required 5G. But if this is a 5G, then this job is much easier, because drone's capacity is boosting because of the unwanted power supply is cut it now. My battery life is getting increased, and I'll be getting a better flight time. So maybe I can get 5 or 6 minutes more on my flight time. Now it will not go, my battery will not go beyond 20-25 minutes, because it is a 3 cells 2300 mAh battery. So that is the capacity what battery is having. But still I can push my battery onto a limit, or we can say that onto a maximum endurance what that battery can provide. So that is why it is having a very low latency. It is a scalable network. Why it is a scalable network? As it is connected to a multiple nodes, and it is having a very beautiful architecture. I'll be talking about like EMTC, EMBB, URLLC, MMTC, REL 15, 16, 5 NGNR. So I'll be not taking into a very deep, as I said before, that this is not the telecom session. Uh, but still we can understand it how exactly this 5G is interconnected. So it is a scalable network, so we can scale up and scale down our requirements. Means what? If I am having a Raspberry Pi which is connected to my home appliance, maybe my washing machine, or maybe with my car. So if I wanted to utilize a broadband on my Raspberry Pi, so I need to connect with a cellular network using a Raspberry cellular bed, or I can just connect it to a Wi-Fi. But when I don't require it, I can easily scale down that service, but it is not possible in terms of a general devices. But if it is a 5G, then whenever it is required, it can provide a network service. Whenever it is not requiring, it is not holding up that service, it will scale down on a particular particular network services or onto a very limited services. So it can just connect to that device. So that is only the keep alive sessions which is established in that case. So that is what this scalability what we can get. Then the customization, of course, we can have a personalization and customization, robotness and content closer to the user. Now why it is closer to the user? Because it is what we can say, it is a very useful thing when a user is experimenting something and user is doing some changes onto it, right? So, talking about the 5G network, so let me take you one thing. So let's understand how exactly 5G is making a very difference in our life. As if we can see that 5G and IoT technology is, which is a more than just a generation of the wireless technology, as it is what we can say, it is representing a fundamental change in our mobile ecosystem, and it is unleashing a very powerful combination of extraordinary speed what we can experience on 5G, almost a 10 gigabyte per second. That is what 5G is providing, even with the expanded bandwidth that we called as EMBB, that is enhanced mobile broadbands, or we can say extended mobiles broadband, but enhanced mobile broadband is more appropriate word in this case. It is a low latency network. It increases the power efficiency, which driving millions of connected devices. And if we can see, according to the GSMA, 5G connections are expected to grow from 10 millions by the end of 2019, and it is already from 10 millions to 1.8 billion. If we can see, that is what the statistics I'm having, and definitely it will go beyond that from 2025. So that is what the uh, uh, data prediction is. But if we can see that very first iteration of the wireless technology was the first age controller, that is a 1G, we can say, where we can have a cordless voice calls and mobility in that case. So later on, we used to have machine to machine communication, which emerged with 2G spectrum, and then we evolved ourselves into a 3G sector, where the browsing capabilities of the network means the broadband capabilities. Because in networking, if we can see, or in a telecom network, if we can see, there are two types of a service provider. First one is NIC, that no sorry the first one is NSP, that is network service provider, and another one is ISP, that is the internet service provider. So sometime it happens like your cellular network is only hosting your network service. Like you can give a call, you can receive a call, you can text SMS, and you can receive a text SMS. That's it. Nothing else. You will not able to make what we can say voicemail, or you will be not able to do internet surfing and all. So in that case, what we are having only NSP, or that carrier is having only a NSP license in India. As in India, if we can see a TRI rules and the Broadcast Act, then a telecom network or a telecom service provider company should obtain at least one license to operate. That is the NSP license, network service providers license. So if you wish to provide internet service along with your network service, then you need to have another license called ISP license, that is internet service providers license. So that is what the guidelines and the rule what we are observing in India. But maybe these rules are different from countries to country, and diplomatic permissions are obtained. And so there are some countries which when we are having network company and offering a network service, then automatically ISP service is included in your license. But here in India, you need to specifically obtain for. So if you remember about the 3G spectrum scam, then in that also the allocation of the spectrum is disputed, because on the Indian telecom space, we are having a separate network line for, or the network spectrum for the normal voice communication, and another for the data transmission. So I don't want to get into that politics, but see, we gotten a 3G where we are experiencing a better voice quality because of the use of web packets over the network, and we were having a better viewing experience or the browsing experience on the internet side. Then later on we merged onto a 4G network where we are seeing almost 1 gigabyte of a network speed, which is a 4G LTE network, and we are having a very low latency in terms of communication. But nowadays 5G is already implemented in some countries, and in India it is about to enter. How soon it will enter, I don't know, but very soon we can have a 5G. So if 5G comes in India, then it is a very game changer, because it is enabling a faster, more stable, secure connectivity, which having self-driving vehicles to smart grids to renewable energies to AI based factories, flows, robotics, everything will be what we can say leveraged on uh, the 5G network. So if we can see that the current and the future aspects of the 5G network, now currently whatever the network infrastructure we are having, it is on a cloud centric network intelligent centers we are having. So it is what it is, the hosting service provider, where we are having a cloud service providers where we are uploading our data. Now in future when we are having a 5G network, then it can be a distributed network. Now what will happen in these two cases? Now in a centralized connected, or we can say centrally connected centric network, what is happening is we can have a aggregator, and we can have the direct control over the devices, as these devices are interlinked with each other. It is not the distinct devices. But in the case of distributed network, what will happen is are all devices are individually connected to the gateway or to the main node, and it is having independence to communicate with this, and no other way is there that it can communicate with other device, improving a security. Because in some cases what will happen is, like take example of ThinkSpeak. So on the ThinkSpeak we have a public channel, sorry, on a ThinkSpeak we are having a public channel as well as we are having a private channel to operate. But though this private channel is again operatable or again accessible on the ThinkSpeak, and there is no that kind of a security, like if ThinkSpeak wishes, they can check your data, and that data can be obtained. But onto a distributed intelligence system like the blockchain, if we can consider, it is not actually a blockchain distributed system is totally different than the 5G IoT distributed system is totally different, but it is sharing a one common thing, that is the security. As in both the technologies, we will be experiencing independence with the technological advancement of the connection. That's why your security and your data encapsulation is better in this case. So if we see onto this, IoT services on a cloud centric intelligence is totally depend on the central cloud, which is extracting the values. And in a distributed intelligence, we can say it is economic and performance trade-offs, which is IoT use cases are there. I mean, depending upon your usage, depending upon your connectivity, that services is offered. Now here there are some examples of how exactly a distributed functionality can work. So if we can see in a general uh, cloud centric environment, we are having larger latency, big data and aggregated values, then content storage, AI and processing to be onto a generically onto a cloud. But because this data is in nature of, like, this data can be varied, so a big data we can think about. But onto a 5G, we can see a most important part of the 5G is very low latency. So there is a very minimum connection dropouts are there. where we can customized our values, which are the local values. So there are no requirements of the aggregated values or the aggregation. So in this case, we can have a customization done over our valuation. Then definitely content storage AI processings are always there, and which will be in a better shape than the current cloud centric environment. Then what other things we can implement, because these 5G is having a low latency, then we can develop our devices like that device can contain some kind of a AI kind of application. So if we are creating a AI powered application, then on device itself you can have a network ability to perform some kind of operations, like we can have a compute operation, vision, sensing, AI cases, then internal AI optimization. So everything can be done on the device itself, so it is not required to have it on a cloud centric environment. So I forgot to show you one device I'm having, Arduino. I think I have already shown to you, which is a ARM based chipset, Arduino Protenta 87. So Arduino Protenta 87 is a development board which is capable to communicate on a 5G network. So that Protenta board, or the Protenta microcontroller or ARM controller, not the microcontroller, sorry, ARM controller, is enabled to have a AI application inserted in its chip and can perform some basic task. It is not that advanced one, and it is not the beginner, but it is an intermediate. So some basic functionality stack it can perform on the device itself. So because of this, we can have on-premise control for ultra low latency. Then we can have uh, device intelligence assisted by cloud. So this is the feature what we can get. Now this feature can be very well go onto autonomous vehicles or the drones, if we can see, to control that drone and their actions, or the vehicle or that action. So this can be best suitable area where we can develop some projects which can be deployed in agricultural area, where we are having a smart harvester, crop harvesters. We can have a spraying agents where the drones are there and they're spraying the pesticides or anything on that. Then we can have a surveyor drone, which drones are serving on the crops to identify whether some pesticides are there, or some any kind of insects are there who are eating your plants. And according to the instance that category, we can use some kind of medicines, and that automatic sprayers can spray that medicine on over the crop, and we can save that crop. Then once the crop is ready to peel, then automatic harvesters will go and harvest the crop. So there are so many things to invent in agricultural field. So I think IEEE is also working on that, since they are having IEEE agricultural IoT establishment, where they are offering the specific budgets to various task force or research group or researchers for creating sustainable devices which can work in a agricultural field based on IoT. So this is what the 5G can bring to us, where we can have automation, the fast automation to be implanted, and the intelligent systems we can create. Then definitely it can have a distributed processing like the XR. Now what is a XR? XR is extended reality. So right now, we are having augmented reality, where we are seeing some objects by in a 4D or kind of a application, where we can experience that thing without going physically. So there is a extended reality as well, where the connectivity is superb through 5G, and we can experience a lot of things out of it. Even we can see the realistic way or realistic augmented reality, and maybe that is a debatable question, where these kind of application is really suitable for us or not, or the human beings will be lost in a digital world. So that is what the debatable question. But as what we can say, technology persons, we can always think about the new invention. So the XR is what we can see. definitely we can have a cloud storage and their instant access on a 5G, as it is having a very fast and low latency network. Now, this is what the 5G vision is. It can provide fixed wireless access, factories, smart transportation, smart public networks, massive IoT. Now, these are some specific areas where these kind of applications can be perfectly fitted in precision agriculture, construction and mining, digital education, connected healthcare, richer mobile experience, smart manufacturing, retail, smart city. So we'll take all these uh, yeah, case studies one by one. So how exactly we can improve our life with the IoT in these environments. Now, talking about the 5G connectivity and what we can say 5G ecosystem, then we are having a massive Internet of Things. So, can anybody tell me what will be the massive Internet of Things is? Yes, anybody? What is a massive Internet of Things? Okay. Massive Internet of Thing is like big data. Particularly, what is a big data? It is a collection of different types of humongous data where the extensions are very vary, and we need to have unstructured kind of a data table where we need their databases where we need to fit that, and it is a very massive amount of a data. So similarly, a massive Internet of Thing is similar to that when we are having so many sensors and devices connected to a single network. That time that Internet of Things becomes a massive IoT where we are having thousands of lakhs of the sensors which are directly connected. Now, a very small example of the massive Internet of Thing is, but I'm very doubtful whether this example can be fitted into a massive Internet of Thing, but you can relate what exactly MIoT is. That's a massive Internet of Thing is the fast tag infrastructure what we are experiencing. So if we can see in India, there are billions of the cars and mobile vehicles are there which are now enabled with the fast tag. And daily, if you can take the NHI ratio, then you can see daily trillions of transactions are passing on to that. So all these are what these are the connected devices where the RFID tag is there and RFID reader is there. Synchronously, it is working on a single network, that is a fast tag network. Maybe, and that single network is again connected to a different types of a banking network. Someone have Paytm's bank RFID card, like I'm having RFID, like the payment card RFID. Then we can have other banks RFID cards, Airtel's RFID card, Bank of India, Bank of Baroda's ID card, or any State Bank of India's card, or directly from the NHI card. So these are the banking partners which are responsible for deducting amount from the wallet. So again, that network is connected to a several different networks for doing the task. So this is also a kind of a massive infrastructure, and we can have a massive Internet of Thing listed over it. So once we are having 5G connectivity platforms, then we can easily use the massive in IoT infrastructure without any latency and without any disturbance. Then we can have a mission critical control, enhanced mobility, broadband. Then we can have various things to implement into it. Like in a 5G, there are what we can say spectrums like rail 15, rail 16, rail 17. These are the set of 5G standards, not the spectrum, sorry. These are the these are the set of 5G spectrums which we can observe in a 5G. In the near future in India also we can have it. Now the 5G systems will have a new technology in radio frequencies, so that we called it as a 5G NR. NR is for the new radio, because it is defining a extended broadband, mobile broadband industry expansions, long term expansions. So there are various things which are getting involved. Even the beauty of 5G is it is enabled with the EURLLC. Now, what is EURLLC? It is extended ultra reliable low latency communication. Now, all the things which comes on a 5G is super fast. So 5G is super fast compared to the what the generation we are having onto a telecom. That 5G is super fast, and it is not only a fast, it is a low latency network where we can have a communication efficiency onto it. And it is having a lower complexity on the LR. It is having extended reality. It is having in-band EMTC and NB-IoT. Now, when we say EMTC is enhanced machine type communication, and NB-IoT is narrowband IoTs. So that there is a network called narrowband IoT. So now, what this narrowband IoT network is performing, once we are having a particular device, like we can have a LoRaWAN device. So this LoRaWAN device will have a extended network capability, but it will require a very low bandwidth to communicate on a network. So that's why, and the spectrum which is getting allocated to that radio frequency is again a very limited and very narrow. So these kind of technologies are example of narrowband IoT. So 5G again having a lightweight protocol to be implemented on the network spectrum, and once a device is connected on the 5G spectrum, it becomes a NB IoT device. Though some hardware changes needs to be performed in a device to be able to communicate on the 5G spectrum. So at least we required a 5G 5G connector, and we need to have 5G allocators, and then we can have a 5G chipset where we can communicate on it. But how exactly 5G is working? So 5G is what it is: a ultra high speed and low latency, again low latency network, which leverage the radio frequencies in two types of a group. So one first group is FR1, which also called as a sub 6 gigahertz range. So it is also known as a sub 6 frequency. So sub 6 frequency is what it is a type of frequency where the 5G network can leverage. Then there is another frequency, that is FR2, which is having 24 to 52 gigahertz, or between 24 and 52 gigahertz. So that is what the frequencies 5G will be having, and it is FR2 will extend to the extremely high frequency range, that is EHF we called it, like the UHF or VHF we are having. Similarly, EHF will be there for the communication, and it will have a spectrum between 30 gigahertz to 300 gigahertz. So once we are having a millimeter wavelength frequency, then it can extend to that. Now, talking about the MMTC, which is a massive machine type of a communication, which is a very energy efficient communication, which adopts the existing LTE or LP WAN, that is low latency WANs, low powered WAN, or the low latency WAN. Which is a main focus on efficiency and transmitting a low data volumes, which gives our devices a required wide area and the coverage of the wide area. Once we are having a huge number of the data to transmit over the wide area, then we can use LPWAN with the help of massive machine type, that is the MMT, and if we take it into 5G, it can be a EMTC in that case. Uh, So moving ahead on to how we can build the 5G NR system, if we can see on the foundation, if we expect in that, then the main point to be noted will be the mission critical design. If we are having, like we are having system which is working 24 by 7, or your factories which are working 24 by 7. So in that factory we are having robots which are doing all the stuff and around the clock, then there we required reliability up to 100% reliability, but 100% we cannot get, so up to 98 or 99.9% of the accuracy we can observe. So in terms of network and network failure, we can achieve this 99.9% of the accuracy in 5G network. Then it is very convenient to deploy new types of IoT models, and if we are having enterprise level models, then it is very suitable to deploy it on a 5G technology. Then we can have unlicensed spectrum on that, so we can have experiment with it. We can have a high precision positioning. So as 5G is a very low powered and narrow band frequency, does it is having a precision of taking out the GPS coordinates, so we can have a high precision on the positions. So even now also, if you can see, in India at least, once you are opening up a Google Map and you are navigating your car to a certain target area, now once you reach to that target, that map is showing you that your destination will be a left side. And if you can see that area, then it is not actually, sometime it is not actually on the left side, sometime it is showing that in 20 meters radius it can be on the left side. So in 20 meters you have to find out what you wanted to reach, or where you wanted to reach. So this is not the accuracy on the precision. So maybe because of the faulty latitude longitude coordinates, or maybe because of the faulty GPS signals, or low GPS signals in that case. But if we are using a 5G network, then these kind of errors, or we can say these kind of halts will not be there, as this is a very precise connectivity which 5G is offering. So that's why it is a very precise in the positioning. Now let's see what kind of use cases we can have, as this is having a beautiful example. Like if you are having augmented reality goggles, or if you wanted to have some experience on that, then you can have a XR, that is extended reality. So through extended reality you can actually show the picture, or actually now using 5G network, you can live transmit or get a live stream of a some areas. Like there maybe it can be happen on online classrooms as well. So you are on a campus, you are on in a college, and you're teaching onto a board, and there will be a XR camera which is mounted on the table. Then that XR camera connected to a 5G network, capturing your footage, and it is delivering live onto a XR, or the augmented reality goggles, where students are wearing those goggles, and student can feel that they are sitting into a classroom. So that is what the extended reality is, and there is no latency in the network. That's why they will not feel that there is some kind of a virtual interface we are having. So it will look like the real one. They're sitting before you and they're listening your lecture, or they're listening your sessions. So it is kind of experience what we can get on the 5G. And the main technology foundation of the 5G is, it is a coverage optimization, then increased network efficiency. Now how the coverage optimization will be happening: repetition on and building lower modulation side lanes or the relays. So if we can see now, if we wanted to have a range extender or something, we need to have the access point. Or similarly, when once you are calling it, that call, your mobile call is getting connected, or your mobile is getting connected with the tower. So on the tower level there are modulation, or the relays which are opted to modulate your signal, to strengthen your signal. So using lower binding agents onto these devices, which actually will have a low power consumption end, Because of that, they can transmit a good range, and they can get a good reception from your mobile, and they can have a better coverage inside, means the indoor and outdoor both. Sometime we experience now also, if though we are having a 4G LTE, we are experiencing some network failure or connection failure inside, or maybe full range is not there on inside, though your carriers are sending you repetitive messages like you're inside the indoor coverage is now better, but still it is not better in some areas. Then we can have a lower transmit power, enhanced power saving modes, which is a limited mobility and handover, so which will reduce the power consumption at the device side, making that device much operate on much longer time, and its operating life is also increased in that case. Then we'll have a low device complexity because of the narrow bandwidths what we are getting, so the complexity of decoding and encoding the information is not observed in that case. Yes, encapsulation is always there, but unwanted decoding encodings are not observed in that case. Yes, that is the same slide which is repeated over here, but still it is giving you some kind of statistics. Like in a narrow band operation, we can have down to 10 megahertz of a signal, which is having a dual receiver antenna and half duplex operations. Then we can have optimized power consumption, where we can have enhanced low power modems or the modes PSM and EDRX, which works on at least 23 to 20 dBm, so which is a very low level of the consumption what these devices are using onto. And then network enhancement, where the half and full duplex devices are used to reduce control signaling and small data transmissions. And definitely repetition and building up of small payloads, helping the frequencies hopping and relays to avoid side links, so that because of these coverage will be good, and we can recover the coverage in that case. Give me a minute, I'll just take a water. Okay, now moving on to the 5G use cases. So if we have a 5G and IoT, then what kind of a use cases we can have? First use case we can discuss, that is a precision agriculture. Then we can have construction and mining. And if you can see, this is what the billions of dollars economy, or the billions of dollars that business is. It is the $389 billion industry, which is a precision agriculture. Same with the construction and mining, it is 1061 billion. Digitized education, like the same what we are experiencing, but if we have a 5G connectivity, it can be in a better condition. Like we'll see what kind of a conditions we can have. I just explore the one condition where we can have a XR, and user can feel that that user is sitting just before the professor, and professor is explaining the things. So that digitalized education is. Then we can have a connected healthcare. Now this is the most important part, the connected healthcare. Now later on I'll share some video what Qualcomm was having. So that is a very best examples of the connected healthcare, how the 5G is working in that case. Then we can have a richer mobile experiences, smart manufacturing, intelligent retail, connected smart cities. So let's see some of the use cases of it. This slide is having all the use cases inside. Now, if you can see, this is what the actual photograph of smart agriculture, where the production and the efficiency is increased because of the 5G implementation. Now, in India also, we are having these similar kind of instruments, but it is very difficult to operate this instrument in a very small piece of a land. So we will require hectares of a land to perform. But still, those who are having a good land or the good range of a lands, they are using these kind of instruments. These are the automatic harvester machines, or the iterating harvester machine. So here, if you can see, we can automate this harvester machine. We can automate the supply chain machines, where the machines are going. We can have drone placing on these machines to check the what we can say, their work, or whether they are performing it well or not. Even these vehicle can be unmanned vehicles, can be possible. And the research in that area is already going on, and some researchers have claimed that they achieved success in that. So these harvesters are unmanned harvesters, and once we set the coordinates on the GPS, they are moving on to a crop, identifying which crop it is, and depending upon the pressure which requires to have to peel that crop, it will be applying automatically, and they are harvesting the grains, or harvesting whatever the crops are there. They are harvesting it, maybe a fruit or something. Then we can have a smart rover, or we can have a smart drone flying around, which can check the positions, which can send the coordinates, or they send the signal to another drone to spray some pesticides, or to another drone to check whether this crop is having some kind of a disease or not. So if that crop is having some kind of a diseases, or that crop is burnt, or that crop is now not having anything to peel off, then it will automatically send signal to harvesters to stop harvesting, or to change its way part to another field, because or the another area of the field, because these crops are not suitable for the further processing. So that kind of application it can done. So this is what the illustration they are having. So we can have autonomous harvesters. So these are what these smart harvesters. These autonomous harvesters can be filled with what kind of crop you wanted to harvest, and how the harvesting is done on that crop. Maybe that is what your vegetables are, or maybe that can be fruits or something. So there is a intelligent device which is connected, or which is mounted on the top of the shaft, or inside that rower, or that harvester can be intelligent, where that harvester can see what type of crop we need to harvest, what is weather right now, whether we can peel a crop or not, whether we can experience some weather disturbance or not. That weather forecasting can be happened. Then it can adjust its robo arms, or it can adjust the harvester over here, the main harvester at the bottom, according to the landscapes. Because maybe sometime it is not observed that every field is having a straight land. It can have some curves, it can have some step, it can have some kind of obstacle on it. So it can find out that that is what the terrain is over here, and then it can navigate itself. Then we can have a real-time dry chain tracking. So we can have a real-time tracking on the trucks, whether that material truck is arrived or not. If it is arrived, then one of the a truck will come to here, collects the crops, and again back onto a line. That we can do. Maybe it can be a semi-automatic process. Complete automatic process will not be possible in each and every condition. So we can have it on a semi-automatic process. Then we can have the rovers, like I said before. It can have some kind of surveying rovers, or it can have smart sprinklers. It can have a pest detection rover, means the any kind of insects are there on that or not. Then some drones, or the rovers, or harvesters are equipped with moisture sensors to capture the moisture on the field. And all these things can be connected onto a cloud or onto a network using 5G, which gives us a more reliable connectivity. And we can sit in our home, and we can see the live footage if we deployed a drone, and we can control each and every machinery. That way a farmer can control it. And another part would be connecting energy grids from more efficient production, distribution, and consumption. So in this case, we can have a windmills or any kind of non-conventional energy sources, maybe a windmill, maybe water mills. So from there, hydroelectricity plants or something. So from where we can have that thing. Like if you can see, these windmills required some kind of a torque or some kind of a motion first, and then then that windmill is spinning depending upon the direction of a wind. But to start that spinning, it has to have a starter, like like you are starting your car and you need to accelerate it. So similarly, this wing is also needs to be accelerated on a certain type of speed which can match with the wind speed, and then it can automatically rotate according to the wind speed, and then the electricity is started generating. So and that also we can have automation, where we can have a smart energy distribution center, maybe a local distribution center we can have, like the MACB we can now take into a picture, where we are having a distribution lobby center, where we can connect with all these grids, smart grids, and we can see what kind of energy it have what kind of energy it have generated, which windmill is producing more energy, which is not producing it, which is having some malfunctioning, auto work is processing, or kind of a remedial solution is processing. Then it can detect the energy surge during the peak hours in a general population. And if there is a energy peak, surge peak, or the peak energy surge, then automatically that amount of energy will be distributed, or else a stable amount of energy is getting distributed. Then we can have smart lighting, smart grid, fault sensor, where these sensors are detecting some fault. Like for example, if on a certain area, if electricity is it is disturbed, or it is halted because of some, maybe some mechanical failure, or maybe some grid failure, then it can have a latency, or it can have a redundancy line, where from that redundancy line, from the another distribution center, electricity will be supplied, and the essential work will be not halted. So that kind of application we can enable through automation. Even that plant will self test itself what kind of a problem that plant was having, or it is because of the particular device, or particular panel, or particular distribution unit, or what. And it can pinpoint the location, or it can pinpoint the problem area where it can try to rectify itself. Or if it is beyond that machine to rectify, it will notify engineer to go there and rectify the certain things. So that kind of a smart gate fault tolerance sensors we can develop using 5G for better performance. Then in delivering a better customer venue experience, if we can see a live match, then the video streaming or social streaming is much faster into a 5G network. So we can deploy a 5G private network channel, where we can connect multiple cameras, multiple personalized seat connections. So there are various things where we can connect with the 5G private network. So like here we can have autonomous ride share. So we can have our vehicles connected, where we can have taxis and all. Then we can have a smart parking status, whether before entering into a stadium, we can know whether that stadium's parking is full or not, or there is only one vacancy, or there are four five vacant spaces where we can park our vehicle. Or some vehicle will be living in 10 minutes, 2 minutes, so we can wait. So that kind of a real time sensing data can be available. Then we can have ultra high resolution surveillance camera, because once we are having a high definition surveillance camera, then that camera requires more bandwidth to produce that high definition video. So 5G is providing that kind of bandwidth, and it is having broadband with it. So that's why UHD surveillance camera is perfectly working on the 5G network. Then you can have a personalized seat concession. So we can see that if we wanted to have some kind of preferences to our seat, like we like to watch a movie in the middle row or at the last row, so we can have that tracking. But it is actually not required a 5G network, but still we can implement some kind of AI activity with that. Then now if we wanted to see where our seat is in the stadium, then we can have a indoor seat navigation system where it can notify us where you are, and then your seat is where, and it can show the path to reach our seat. Or it can have a smart ticketing, reliable mobile broadband, and so on. So there are various things where we can connect, or we can connect real-time traffic cameras or the traffic lights on a 5G network. But here in India, getting traffic traffic lights on a network, it is not advisable, or it is not feasible. It is advisable actually, but it is not feasible because of the varying type of traffic we are having. Sometime I experience that I'm holding myself on a traffic signal for a minute, and a follow rider with me who is waiting for the signal for past at least 45 seconds, and only a 10 seconds or 5 seconds are remaining, it's breaking a signal and getting out from that. So so maybe that is the tendency what we are having in India, that needs to change. But still this smart trafficking is what the solution what 5G can offer. And 5G can provide a better reliability over the emergency services. So if you can see over here, this situation is very rare in India, that we can have a wildfire, but ambulances or the medical emergencies are very common. So if we can see the medical emergencies, we can have very good connectivity with the emergency services and the emergency vehicles, where we can track emergency vehicle prominently, and it will send a signal to the connected traffic lights to change direction, or can operate properly. So there can be a smart traffic solution where if emergency vehicle is going from one direction to another direction, then automatically it sends a signal to the nearby traffic lights by stating that I'm having an emergency and I'm passing through you. Then automatically, depending upon what type of traffic it have already managed, then it can manage the traffic like the way it can make a way for that emergency vehicle to pass from that area. So that kind of application we can think of. Now we can think about 5G and IoT in terms of warehousing or logistics and containers, because this is a biggest industry, and it is a very challenging area where we can implement automation, because real-time asset tracking is also important in this case. Real-time container tracking, and one ship can hold thousands of container, and these needs to be unloaded and loaded every time. These ports are very busy in that case. So freight manifest, when the freight manifest is uploaded on our system, then it can automatically detect which number of container is belongs to which company, and if I'm going to claim it, then automatically I can get the what we can say location of that container, and I can remove it. So aligning the containers, having handling of the container, site operations, then AR guided repairs. So all these kind of surveillance again, then fallback public network. So if there is a very high traffic of the containers truck, then we can control the traffic accordingly. So there are so many things, or there are so many ways where we can actually enable 5G, and we can implement these solutions. Even the similarly, we can have a flexible manufacturing where we can have robotic arms digitally embedded. Then we can have a predictive maintenance, like this robotic arm will require this maintenance in 4 days, 5 days. This kind of application we can develop. We can have autonomous guided vehicle to give the raw material for drones or these robotic arms to stitch, or maybe whatever the material is there which needs to be mounted on that PCB or mounted on that final product, that will be continuously getting supplied from the warehouse using autonomous guided vehicles. We can have equipments which are wirelessly connected to monitor all the things, where we can have a private 5G network, or we can create a 5G network interface where we can control all the things, right? So there are so many things where we can control our automation. Like in mining operation, we can have a operation in airports. We can have in crowded areas, rail stations, then warehousing, smarter warehousing, which is a very prominent areas now, because smart warehouse solution is everybody looking at. And because of the growth in e-commerce industry, smart warehousing solutions are very demanding. Then we can have efficient driving capabilities, tracking, traffic modeling. Then specifically in healthcare, if there are the healthcare industry, then we can monitor patients' health properly with the help of 5G network, without having any delays. So patient vital signs and all, it can be if there is a emergency, then we can scan that patient through any some kind of a device what we can create, and that entire information can be obtained from that device and will be available to doctor who is treating that person. Maybe that kind of, it is a ambitious project what we can take, because in India, though we are having Aadhaar card, which supposed to work like green card, or so not, sorry, not the green card, like the social security number in some countries like America, New York, America, London, means the England, Canada. So in that case, they are having social security number, which is similar to our Aadhaar card, but they are having a very good system that by birth only they are there to that system, so they are having their data very properly. Though we are improving ourselves into Aadhaar case, and if the Aadhaar is collecting data related with your healthcare, your allergies and all, then it will be very useful for our applications to detect what kind of past disease that patient was having, or a medical condition that patient was having. It will help treating doctors, understanding allergies and understanding all the other health factors of that patient, so that we can have it. And the classroom, smart classroom, we just discussed about. Same thing with the real experience. We can have we are kind of experience where sitting here we can shop around, we can go virtually in every shop, we can take out the items, or we can put into a card, we can pay for it. Then there will be a delivery drone which is going to deploy, and that drone will deliver your package to your home. So that also can be uh, properly managed through 5G network. And there are limitless possibilities. So yet 5G yet to come in India, but we are ready for the 5G, or that is the question. We are really ready from a technological point to embrace 5G or not. But still, 5G will give us a very what we can say advantage over the IoT applications, and we can create very sustainable applications through 5G connectivity using IoT or using IIoT, that is Industrial Internet of Things. So, yeah, so I guess this is from my side for today's session. We are open for question and answers. If we are having any question answers, yeah, we are open for it. Yes, participants, if you are having any question, if you wanted to add something in this, if you wanted to give something to us, please ask any questions if you are having. So I guess there are no questions. So again, thank you very much for listening me and connecting with us on this Sunday. We'll see you in next session. Thank you.